Hello everyone, we will solve one more problem in simplex method. The given LPP is in which form? Max z is equal to 6x1 plus 8x2 subject to the constraints. First constraint is 5x1 plus 10x2 less than or equal to 60. Second constraint is 4x1 plus 4x2 less than or equal to 40 and x1 x2 greater than or equal to 0. Now we will solve using simplex method. To solve using simplex method, we have to convert the given problem into the standard form. While converting into standard form, observe the objective function. It is in the maximization type. Therefore, we can write as it is. Max z is equal to 6x1 plus 8x2 subject to the constraints. Subject to the constraint. First constraint is having less than or equal to symbol. That's why we have to add one slack variable on the LHS side. And second constraint is also having less than or equal to symbol. That's why we have to add one more slack variable on the LHS side of the second constraint. So that the constraints will become 5x1 plus 10x2 plus s1 is equal to 60. Second one is 4x1 plus 4x2 plus s2 is equal to 40. And constraints, decision variables x1, x2, as well as s1, s2 greater than or equal to 0. All these decision variables and slack variables greater than or equal to 0. Like this, we have to convert the given equation into the standard form, given LPP into the standard form. After converting into the standard form, we have to draw the simplex table. How to draw the simplex table? I'll tell you. Now first initial simplex table. To draw the initial simplex table, first draw the line like this. And first column, second column, and first column is for CB and second column is for basis B and third column is for the body of the simplex table. The body of the simplex table, first how many variables are there we will see. If you see the variables x1, x2, s1, s2 greater than or equal to 0, that means total how many variables are there? 4 variables we have, x1, x2, s1, s2. That's why we will write x1, x2, s1, s2 and one more, we will draw one more line, and this is for constant. Whatever the right side of the constraints, whatever we have, that constant we will write, and then minimum ratio column in the end, last column. Now draw one more line like this. Now this is the table, and then next is CJ. Write down here as CJ. CJ means what we should write in the maximization Z. Whatever the coefficients of x1, x2, s1, s2 is there, that one we should write. Max Z is equal to how much there? Coefficient of x1 is 6. Coefficient of x2 is 8. Any coefficient of s1 is there? There is no s1. There is no s2 in the objective function. That's why we can write CJ as coefficient of x1 is 6 above x1, coefficient of x2 is 8 above x2, and s1 there is no s1, that's why 0, there is no s2, that's why 0. Like that we have to write the CJ elements above the table, above the table. CJ we should write above the table. Now first we will fill the body of the simplex table. While filling the body of the simplex table, just observe the constraints very much carefully. The constraints are, the first constraint is coefficient of x1 is 5, coefficient of x2 is 10, s1 is 1 and RHS side is 60. So that what we can write, coefficient of x1 is 5, 10, coefficient of s1 0, this is 0 and constant is 60. And coefficient of second constraint is 4x1, that's why 4 plus 4x2, that's why again 4. Coefficient of s1 0, coefficient of s2 1 and RHS side is 40. And draw one more line like this, we will get like this. Now if you observe the second constraint, coefficient of x1 plus coefficient of x2, s2 like this is there, that's why I wrote like this. And after filling this one, now if you close this x1, x2 part, you will get a S1. Just if you see, observe, here we will get one identity matrix because only 2 rows occurs. That's why we have got a 2 by 2 identity matrix. If is there any 3 rows occurs, we will get 1 0 0 3 by 3 identity matrix as 1 0 0 0 1 0 0 0 1. Here wherever you get identity matrix, that variables, and here that variables called variables are called basic variable or basis. Here 1 0 0 1 is the identity matrix, and near S1 and S2 we have got. That's why the basis or basic variables are S1 and S2. Now if you see the CJ column, coefficient of S1 is 0, coefficient of S2 is 0. That's why 0 0 we should write constants of the basis. Now after that draw one more line like this. This row is called index row. This row is called index row. We have to calculate index row using the formula Zj minus Cj. How to calculate index row? Using the formula Zj minus Cj. How to calculate Zj minus Cj? I'll tell you. Just listen. How to calculate means 0, this column, CB column into first column. Now that means 0 into 5 plus 0 into 4 minus CJ minus 6. Here we have to write. And in the same way 0 into 10 plus 0 into 4 minus CJ. Here we should write. And 0 into this plus 0 into this minus 0. Here we have to write. 0 into 0, 0 into 1 minus 0 minus CJ. We have to write like that here. Now this is the formula how to calculate Zj minus Cj using this formula. But here in this is called initial simplex table. In the initial simplex table, the CB values are 0 0. We have got 0 into anything is 0. That's why here while calculating the index row elements, whatever the values are there here, quite opposite values only we will get, because CB values are 0 0. That's why whatever the CJ values are there, just quite opposite values only we will get here, because of zeros occurs here. That's why. Now that means here minus 6 minus 8 is 0 0 is you'll get. That means if you multiply also 0 into 5 plus 0 into 4 minus 6. Now 0 into 10 plus 0 into 4 minus 8, like this you will get. Now after calculating the index row elements, this is the basic initial simplex table is over. Now we have to go to the first iteration. How to go to the first iteration? You have to observe the index row very much carefully. Using the index row only, whether we are going to the next iteration or not, we can identify. Whether we can reach the optimality or not, we can identify using the index row only. That's why observe the index row very much carefully. When will you reach the optimal condition? Whenever all the index row elements are greater than or equal to 0, then only we can reach the optimal condition. Otherwise, we have to go to the next iteration. That means either 1 or 2 negative values occurs, we have to move further for the next iteration. Here if you observe, we have got 2 negative values in the index row. That's why we have to do, just observe the complete index row very much carefully. Identify the most negative value from the index row. Here the most negative value is minus 8. That is most minimum value. Most minimum value or most negative value is identified. That is minus 8. After that, coming to the minimum ratio value. The minimum ratio. How to calculate the minimum ratio? Identify the most minimum value is this one. That means I choose the x2 column. After choosing the x2 column, coming to the minimum ratio, I choose the x2 column. That's why 60 minimum ratio is this constant by the choosed column. 60 by 10. 60 by 10 is equal to 6. 40 by 4. Here 40 is there, constant by this column element. 40 by 4 is equal to 10. Now 60 by 10 is equal to 60. 40 by 4 is equal to 10. The most minimum value here is out of the minimum ratio. In the minimum ratio means, how to identify minimum ratio? In the minimum ratio contains any negative value or infinity value. Just you can ignore that value. Out of positives and zeros only, we have to choose the most minimum value. Once again, remember, minimum ratio contains either negative values or infinity value. We have to ignore. out of either 0 or positives only, we have to choose the most minimum value. Now if you observe the most minimum value here, out of 6 and 10, the most minimum is 6. That's why I'll put one more arrow like this. That means I choose the first row. I choose the first row. So that we have got like this. That means I choose the first row. S1 is leaving variable, whereas X2 is entering variable. S1 is leaving the basis, whereas X2 is entering the basis. If you come like this, this is the coincide element. For this coincide element, we have to put one box for this one. That box, that element is called pivot element. That coincide element is called pivot element. What we have to do with that pivot element? The simplex procedure is, we have to convert the pivot element into 1. The above or below elements, is there any? We have to convert into zeros. Now the pivot element, how to convert the pivot element into 1? Now before that, S1 is leaving variable, X2 is entering variable. S1 is leaving, that's why we will leave S1 and we will enter X2. In place of S1, we are entering X2. Above X2, how much is there? 8 is there. Now this S2 as it is, I will write, and 0 also as it is, I will write, and one more line I will draw like this. And we will convert the pivot element. We will convert the pivot element into 1 by dividing the complete row, dividing the first row completely by 10. How to convert 10 into 1? To convert 10 into 1, we have to divide the complete row with 10. So that how much you will get? 5 by 10. 5 by 10 is 1 by 2. 10 by 10 is 1. 1 by 10 is 1 by 10. 0 by 10 is 0. 60 by 10 is 6. Now what we have to do? Now the next step, what we have to do? We have to convert this element into 0. How to convert this element into 0? I'll tell you one shortcut method. Now whatever the element, first of all, just listen carefully. Whatever the element you are going to convert into 0, that element, that row completely you write down. Which element we are going to convert into 0? 4. This one we have to convert into 0. Now the complete entire row I will write first of all. 4, 4, 0, 1, 40. After that, after converting that pivot element into 1, after converting the pivot element into 1, how much you have got? Whatever the row you have got, that row we should write any below that row. 1 by 2, 1, 1 by 10, 0, 6. Now in which place we have to get 0? In the second place. Here 0. Second place means to get 0 here. We have to get 0 here. Remember what I wrote? This is the old row. Old row means whatever the element we are going to convert into 0 is the old row. Which one is the new row? New row is after converting the pivot element into 1, whatever the values you have got, that is a new row. This is old row, this is new row. Now we have to get the second place 0, second element into 0. That means to get 0 here, the second row, what we have to multiply the second row with? We have to multiply the second row with 4. Just remember, to get 0 here, that's why I wrote 0 here. To get 0 here, I have to multiply the second row with 4. So that you will get, what you will get? I will write the first row as it is, 4, 4, 0, 1, 40. Now 4 into 1 by 2. 4 into 1 by 2 is 2 ones are 2 twos are 2. 4 into 1 is 4. 1 by 10 into 4 is 4 by 10. 4 by 10 is 2 by 5. 4 into 0 is 0. 6 into 4 is 24. Now the second place we have to get 0. To get 0 here, we have to subtract the complete row. Now then only 4 minus 2 is 2. Plus 4 minus 4 get cancelled 0. 0 minus 2 by 5 is minus 2 by 5. 1 minus 0 is 1. 40 minus 24 is 16. That one I will write here. 2, 0, minus 2 by 5, 1, 16. Like this we have to do the rough work very much carefully. Old row first, next new row, like that. Now whatever the value you have got, that one I wrote here. Now in the next we have to calculate again index row. How to calculate index row? What did I say just now? Zj minus Cj. Zj minus Cj means this is CB column into first column minus Cj. That means 8 into 1 by 2 plus 0 into 2 minus 6. That means how much you will get? 8 into 1 by 2 is 2 ones are 2 4s are plus 0 minus 6. 4 minus 6 is minus 2. Here 8 into 1 plus 0 into 0 minus 8, 0. 8 into 1 by 10. 8 into 1 by 10 is 4 by 5. 4 by 5 plus 0. 8 into 1 by 10 plus 0 into minus 2 by 5 is 0. 8 by 10 is 4 by 5 minus 0 is 4 by 5. 8 into 0 plus 0 into 1 minus 0, 0. Now 8 into 16 is 8 into 6 is 8 6 are 48 plus 0 into 16 is 0. That means here 48. Now coming to the minimum ratio. How to calculate the minimum ratio? Before going to the minimum ratio, just observe the index row very much carefully. In the index row, any negatives occurs, then only we have to move further for the next iteration. If all the values are positives and zeros, all the values are greater than or equal to 0, we can stop the iteration and we can write we reached the optimal condition. You check it out first whether we reached optimality or not. Now if you observe the index row carefully, one negative symbol is there, minus 2 is there. That means we did not reach the optimal condition. That's why observe the index row very much carefully. The most negative or the most minimum value, or most negative value in the index row is minus 2. Put one arrow here. Coming to the minimum ratio. That means here I choose this first row, means first row I choose the x1 row, first column. I have chosen the first column. Now coming to the minimum ratio, constant term is 6 by 1 by 2. 6 by 1 by 2 is equal to 6 2s are 12. Now 16 by 2. 16 by 2 is equal to 8. Now 1 by 2 I choose this column, that's why constant by this column element. 16 by this column element if you choose, we have got 12 and 8. Now just now I told you minimum ratio, if you get any negatives or infinity, just ignore. Out of positives and zeros only you have to choose the most minimum value. Here the most minimum value out of 12 and 8 is 8. Out of 12 and 8 is 8. That's why I choose this row. Now this row means if you come like this, S2 is leaving variable, whereas X1 is entering variable. If you come like this, X1 is entering variable. S2 is leaving the basis, whereas X1 is entering the basis. The coincide value, if you observe like this, if you come like this, the coincide value is 2. That means 2 is the pivot element. What we have to do with that 2? We have to convert the pivot element into 1 and the above value into 0. Now first first row I'll write as it is. First these two columns, 8 x2, and s2 is leaving variable, whereas x1 is entering. X1 is entering. Above x1 how much is there? Above x1 6 is there. 6. That's why we will write 6. Now we have to convert this 2 into we have to convert the pivot element into 1 first of all. Now how to convert the pivot element into 1? Divide the complete row with 2. 2 by 2 is 1. 0 by 2 is 0. Minus 2 by 5 by 2. Minus 2 by 5 by 2. That is equal to minus 2 by 5 into 1 by 2. That is equal to minus 1 by 5. That is equal to minus 1 by 5. Next 1 by 2. 16 by 2 is 8. That means I divided the complete row with 2. This row is there. This row I completely divide the row with 2. 2 by 2 is 1. 0 by 2 is 0. Minus 2 by 5 by 2 is minus 1 by 5. 1 by 2. 16 by 2 is 8. Like that I multiplied. I divided the row with 2. And then what we have to do? We have to convert this element into 0. Whatever the element we are going to convert into 0, that is called old row. That row first I will write 1 by 2, 1, 1 by 10, 0, 6. This is the old row. Old row means whatever the element we are going to convert into 0, first we have to write that row. After that, after converting the pivot element into 1, whatever the row you have got, that one is new row. That new row I will write 1, 0, minus 1 by 5, 1 by 2, 8. Now this is the old row, this is the new row. Old row means whatever the element we are going to convert, into 0 is called old row. Now whatever the new row is, whatever the element we converted into 1 as new row. Now in which place we have to get 0? In the first place. Here we have to get 0. To get 0 here, we have to multiply the new row with 1 by 2. To get 0 here, multiply the new row with 1 by 2. The old row as it is, I will write 1 by 2, 1, 1 by 10, 0, 6. 1 by 2 into 1 is 1 by 2. 1 by 2 into 0 is 0. Minus 1 by 5 into 1 by 2 is minus 1 by 10. 1 by 2 into 1 by 2 is 1 by 4. 8 into 1 by 2 is 2 ones are 2 fours are 4. Now here to get 0 here to get a 0 here, what we have to do? We have to subtract. To get a 0 here, how can we get the 0 here? By adding or by subtracting? By subtracting only we will get a 0 here in this place. Subtracting. Whenever you do the subtraction, we need to change the signs. Plus 1 by 2 minus 1 by 2 cancel 0. 1 minus 0, 1. 1 by 10 plus 1 by 10. 1 by 10 plus 1 by 10, 2 by 10. 2 by 10 is nothing but 2 by 10. 2 ones are 2, 2 fives are 1 by 5. 2 by 10 is nothing but 1 by 5. 0 minus 1 by 4 is minus 1 by 4. 6 minus 4 is 2. Like this we have to do the simplifications in separate paper always. Now here I will write all the values 0, 1, 1 by 5, minus 1 by 4, 2. After that I will continue the problem. I will find the index row. Whether we are going to, after finding the index row only, we can find whether we are going to the next iteration or we reach the optimality. We will check. Now how to find the index row? What did I say? Zj minus Cj. Zj minus Cj, how to calculate? The CB column into first column. 8 into 0, 0. Plus 6 into 1, 6. Minus 6. Minus 6. How much you will get? 0. Here minus 6 is equal to 0. Now 8 into 1 is 8. Plus 6 into 0 is 0. Minus 8. Here also you will get a 0. Now 8 into 1 by 5. 8 into 1 by 5. Any simplifications you do in rough work separately. 8 into 1 by 5 is 8 by 5. Plus 6 into minus 1 by 5. Minus 6 by 5. LCM is 5. 8 minus 6 is 2 by 5. Here minus 0 is 2 by 5. That means 8 into 1 by 5 plus 6 into minus 1 by 5 minus 0 is equal to 2 by 5. Now 8 into minus 1 by 4. 8 into minus 1 by 4 is 4 ones are 4 twos are minus 2. Plus 6 into 1 by 2. 6 into 1 by 2 is 2 ones are 2 threes are plus 3 minus 0. That is equal to plus 1. You will get minus 2 plus 3 is minus 2 plus 3 is, do the simplification separately. This into this plus this into this minus 0 is equal to 1. Here now we will multiply. 8 into 2 is 16 plus 6 into 8 is 48. 48 plus 16. How much you will get? 64 here. 8 into 2 plus 6 into 8 is 64. You observe the index row. Observe the index row very much carefully. What you have got? We have got all index row elements are greater than or equal to 0. You check it out. All index row elements, write down. All index row elements are greater than or equal to 0. Therefore, we reached the optimal condition. Optimal condition is all are greater than or equal to 0. All index row elements are greater than or equal to 0. We reached the optimal condition. Now here, after reaching the optimality, the right side corner, whatever the value is there, that value is the max z. Max z is equal to that 64 at x1 is equal to 8, at x1 is equal to 8 and x2 is equal to 2. This is the answer. If you want to check, if you substitute x1 is equal to, if you substitute x1 is equal to 8 and x2 is equal to 2 in the objective function, x1 is equal to 8, x2 is equal to 2 in the objective function, you will get 6 8s are 48 plus 8 2s are 12, that is equal to max z is equal to 64. You will get like this. You have to do the simplex method problem. Like this is the simplex method. Thank you very much.